Here's a sample problem. Determine the power of a heavy equipment that performs 55,000 joules. Or if we divide this by 1,000, I think it should be 55 kilojoules if you divide it by 1,000 in 1.1 seconds. So very fast, ano? Approximately or around 1 second, it can already perform this much work. So power will be equivalent to work divided by time. Work is 55,000 joules in our example divided by 1.1 seconds. That's the time. So if we divide the two, what will be getting is 50,000 watts. Or if we want to express this in kilowatts, we just divide by 1,000. So 50 kilowatts. Here's another example. Determine the power performed by a 60-kilogram man running up the stairs with a height of 4.5 meters. 4.5 meters is the height of the stairs, not the man, in 4 seconds. We have some hints here on how to solve this problem. So meaning to say, you can also compute for the power of a human person, not only those of a machine. Let's analyze this example a little bit more. So power can be computed using work over time. So time is given here, 4 seconds. The man has to climb the stairs, or the man climbed the stairs in 4 seconds. Now, our problem is how do we compute for the work? And what's the object of interest in this time? So what we want to do here is for the man to lift himself from the bottom of the stairs to the top of the stairs. The stairs has a particular height, 4.5 meters. In other words, the man has to displace himself from 0 meter to 4.5 meters. So we already understand our displacement. Now, how do we compute for the force? What force are we? How much force do we need to have here for the man to lift himself up, to run to the top of the stairs, if the stairs has a height of 4.5 meters? So the question is, how much force do you have to exert on yourself to lift yourself up if you have a mass of 60 kilograms? So in other words, you want to determine your weight. Your weight is 60 kilogram times acceleration due to gravity, 9.8 meter per second squared. Kilogram times meter per second squared is newtons. So what we have is a weight equal to 588 newtons. This means that your body has to counter your weight. Your weight is directed downwards, right? So you have to counter this weight. You have to give yourself an upward force equal or greater than 588 newtons. Let's go for the minimum here. So let's say equal to 588 newtons. So your work that you have to apply on yourself is force times displacement, 588, times the height of the stairs, 4.5 meters. So if we get the product of the two, that will be 2,646 joules. How fast did the person do the work? We can power. 2,646 joules divided by 4 seconds. Joules divided by seconds is watts. And the division will be 661.5 watts. Okay.